everyone. If you've been listening to my podcast for a while, and if you've been checking out these news episodes pretty regularly, then you might remember an episode that I made about a year ago, I think about 11 months ago or so, where I talked about the TRAPPIST-1 star system. In that episode, I talked about how the outer 4th, 5th, and 6th planets in this really exciting and fascinating planetary system, those planets were in the habitable zone, and that there was a potential that they could have liquid water. But I also mentioned how these planets are believed to be tidally locked, which would mean the temperature differences on the planet's surface would be extreme. I talked a bit about a potential terminator line, and how it might be a moderate place for life under very specific circumstances. And I talked about the gravity interactions of these planets that are orbiting so close together, and how they might induce tidal heating on one another. In general, I talked about the potential for alien life in the star system based on what we currently knew at the time. And now there's a lot more for us to know. There's a lot more information that's out there because of research. And it makes my previous description of a TRAPPIST-1 star system that's potentially rich with life, it makes that seem pretty hilariously naive and optimistic. The TRAPPIST-1 star system is really interesting. It's a small dwarf star that's tightly orbited by 7 terrestrial planets. Now that some more studies have been done looking at it, we have a much clearer, more accurate picture of what that star system is and what its planets are really like. The study that I want to talk about today was conducted by researchers at the Swiss University of Bern and published in the journal Astronomy and Astrophysics. In it, the researchers looked at each planet individually. All of the planets are Earth-like, with the largest being 1.16 Earth masses, and the second smallest is 0.77 Earth masses, which is significantly larger than Mars. The smallest planet in the system is just 0.3 Earth masses. They also all have a gravity that's relatively similar to Earth as well, although it tends to be a bit lighter than Earth gravity, but it's similar. The largest planet has about 0.96 Earth gravity on its surface, and that's at the high end. And the smallest planet has 0.48 Earth gravity, and that's on the low end. And the rest of the planets have a surface gravity somewhere in between 0.8 and 0.9 Earth gravities. The Most Earth-like of these is planet E, which has a terrestrial core at 0.91 Earth radii, 0.77 Earth masses, and 0.93 Earth gravity, which also receives an amount of radiation from its parent star that's similar to the amount of radiation that's received by Earth from our parent star. Unfortunately, this is where the similarities with Earth appear to stop, and the chances for life existing kind of get dashed upon the rocks, so to speak. The researchers found that most of the planets are covered in volatile gases, or ices, or liquid water oceans that could not support life. The amount of water they estimate some of these planets to have would make them complete ocean worlds, with a water column so deep that the pressure near the bottom would turn the water into ice, and this ice would encase the terrestrial surface, or the ocean floor. It would encase it in a frozen shell. Now this is really important for potential life, because a frozen shell covering the mineral surface of the planet would block the mineral surface from leaching nutrients like phosphorus and iron and sulfur into the water. And these are like the chemical seeds for life, alongside carbon and oxygen and nitrogen. I mean, life as we know it, at least. This planet-wide blockage would pretty much shut down any biochemical life cycle before it got started. And it means that these potentially massive, expansive oceans are empty. They wouldn't have the nutrient mass or the chemical cycles to support complex life. Maybe, in a best-case scenario, there's limited microbial growth. Maybe. Furthermore, the most promising planet for life, planet E, appears to be unable to host an enriched atmosphere above its terrestrial core. Unless it had an impossibly huge amount of gas in its atmosphere, the planet isn't able to hold on to an atmosphere in the first place, considering all of the dynamics of tidal heating and tidal locking and other physics phenomena that I really don't understand. I was going based off of a lot of what the authors were describing in their abstract and in their results section, but the general takeaway was that this planet wouldn't be able to hold on to an atmosphere. And the inability to hold on to an atmosphere, there's a lot of implications there for radiation shielding, for heat retention, a lot of stuff. And this all has consequences for any potential life. And based on the data that they saw, I have a hard time seeing life living here. The TRAPPIST-1 system is definitely unique and interesting, but it's kind of a bummer that the latest research isn't more, uplifting with regards to the prospect of potential life. Now, I still won't rule out life, like bacteria or those rare microbes. I don't think it's an outright impossibility here, because there's a lot that we still don't know about these planets. But I can definitely say that the latest data is certainly not supportive of the idea that the TRAPPIST-1 system hosts extensive life forms. It's a bummer, that's kind of lame. But the universe is a big place. There's quite a few more star systems out there, quite a few more planets out there that could host life, and I'm certain that somewhere, life is out there. We just have to keep looking for it.